to today's lesson on natural science. Our topic is going to be uh, energy transfer in electrical systems. Okay, all right. So our main topic is, as I said, energy transfer in electrical system, and then we are going to look at circuit and electric current. Okay, so our lesson objectives are, by the end of the lesson, you should be able to define an electric current. You should be able to define an electric circuit. Where does the energy come from in a circuit? And these some components of the circuit. Okay, now, so let's just look at, in the last chapter, we looked at static electricity. That was yesterday. We are now going to focus on current electricity. I'm sure you are already familiar with the concepts and terminologies about electricity from previous lessons. So we are just going to revise on about some of these concepts, and we can also extend our knowledge about electricity further. Okay. Now, so let's get going. So we are going to look at circuit and electric current. All right. Now, what is an electric current? An electric current is the movement of charge in a closed conducting circuit. Okay. The electrons in an atom are arranged in an outer space around the central nucleus. I'm sure you are already aware of that. Okay. In metals, the electrons are able to move freely within the metal. The electrons are not associated with a particular atom in the metal. We say electrons in a metal are delocalized. So that's why metals are able to carry charges from one point to another. They are delocalized, means they are not stuck, they are free to move. So a picture of delocalized electrons, or a picture of a metal with the charges are indicated there. So an electric current is simply the movement of charge in a closed conducting circuit. So the electrons must be able to move from one place to another. So materials that are able to do that are mostly the metals, and their electrons are delocalized. Sorry, and because they are delocalized, they are able to move freely and from one place to another. All right, sorry, let's move on to conducting wire. Conducting wire in an electrical circuit is made of what? Metal. So if we supply it with a source of energy and a complete circuit, then the electrons are able to move in the same general direction throughout the wire. The movement of electrons through a conductor is then known as what? Electric current. So here you see that the charges are moving in a certain direction. Let me move back to the previous slide, and then you will see. So look at here, the arrangement of this one, of these delocalized electrons, and this one is slightly different. This one, the arrows, the previous ones, the arrows, they were not moving in a particular direction. They were random. They were disorder there. But if you check here, the arrows are in order, or they are uniform. So when they are moving in this direction, in a particular direction, then they are able to convey what? Certain current. Okay. All right. Now, so let's look at an electrical current. An electrical current or circuit, we said the electric current is basically the movement of what? Electrons or charges. Now, this current moves in a what? In a circuit. So an electrical circuit needs a source of energy. So for an electrical circuit to work, it needs a source of energy. And the source of energy here is a cell or a battery. And then we have got, a cell is just one, but when we have got a collection of the cells, then we get a what? A battery. Now, two, cells have positive and negative terminals, and a circuit is complete halfway for the what? Electricity. So as we can see, we have a bulb, we have a cell, and then we have got a key. So when you connect all these ones, and then the bulb is on, then we say the circuit is closed. So basically, when we come to circuit diagrams, we have got two types of circuit. We have a closed circuit, and an open circuit. So what you have here is a closed circuit. So the circuit must be closed in order for a device to work. So here, if the key is on, then the bulb is light. Then it means that's a complete circuit, such as a bulb which lights up. We can say that an electric circuit is a closed system which transfer what electrical energy. So this is where the topics come in. We are talking about energy transfer in an electrical system. So an electrical system, the circuit diagram or the circuit is a basic illustration of that. So it's closed when the key is on, and when it's on, the bulb will light. And when the bulb lights, then it means there is what energy, electrical energy that has been transferred to the bulb. That's where it's on. Now let's look at point 5. A circuit is made up of what? Various components, which we will look at in more detail later. All right. Now let's go on. So let's look at a circuit component. A complete circuit is a complete circuit is a complete conducting path for electricity. So the previous lesson, if the bulb is not on, then the bulb, if the key is not on, the bulb will not light. So if the bulb is light or is lit, then it means we have a complete circuit. So when we have a complete circuit, then it means there is a path or a conducting pathway for the electricity. So it goes from one terminal of a cell along conducting material through a device and back to the other terminal of the cell. Okay, but there are certain parts or components that are able to convey this energy that is moving about from one terminal to the other. Okay, so the cell, as we have seen in the previous diagram, this is how it's illustrated. And what is the function of the cell? Is what it acts as a source of energy for the cell, and this is the symbol. You have one terminal that is bigger than the other one. Now let's look at a touch bulb. We have the touch bulb. That's what provides a light source, and you have the symbol there. You have a cycle with a cross and with some terminals at the other side, indicating also that those ones can be connected to wherever you want it to be. Now the switch, so an open switch. So generally we have a switch, but the switch can either be open or closed. So the function of an open switch breaks the circuit and prevents current in the circuit. So you see that this is open. So that is an open circuit. Now we have a closed circuit, and a closed circuit a closed switch is a switch which completes the circuit and allows current to move in the circuit, as you can see here. Now, what we are seeing here is an electrical wire. And what is the function? It conducts electricity in the circuit, which provides a pathway. So it's just like a line that is drawn. So basically, these are some of the few components that an electric circuit should have or possess. All right, now let's go to effects of electric current. Now, when you have a complete circuit, then it will transfer what electrical energy from one terminal to the other. So as this transfer is moving on and the bulb is light, indicating that there is charge flow, there is a certain effect. Okay, so an electric current can basically generate heat. After some time, if the bulb is on, if you touch it, there is heat. So it means the effect of that electric current is generation of heat. One effect is that it can also generate a magnetic field, and another effect is that it can cause chemical reaction in a solution. Okay, so let's look at them. Let's look at the heat effect. As electrons move through a resistor, they encounter resistance and they transfer some of their energy to the resistor itself, which in effect leads to the heating effect. Now, this heating effect can have a negative impact or a positive impact. but mostly is a what? A negative impact. Now, so that's why objects or appliances that are connected to electricity or electrical source need something that will try to safeguard that appliance. So if the heating effect or there is too much surge of electricity, then automatically there should be something that will break this current so that the system will what be safe. Now that leads to what is called fuses. Okay. Now what is a fuse? Okay, we will come to the definition, but for now, let's move on to what I'm explaining now. The heating effect of an electric current can be dangerous, as I was saying. If a circuit overheats, it could cause a fire. To avoid heating, circuits often contain a fuse. Okay, fuses contain a what? A low resistance wire made of a metal with a low melting point. Therefore, the piece of the wire melts if it gets too hot to protect the what? The component or appliances as I was talking of. Yes. So because of the effect of electric current, it will lead to what? A heating effect. And now heating effect will have a negative impact. So to avoid or circumvent the what? The heating effect, then there is something that is designed to be placed in appliances such that when the electricity is so high, then the circuit will get broken by getting blown. So if I may use that word. So when it's blown, then it's only the fuse that is affected, but your appliance is still working. So you just need to replace the fuse, and there you go, your appliance is still working. All right. Now, so let's look at the fuse itself. So what is the fuse? A fuse is just an item or a part of an appliance that regulates the amount of current entering the appliance. So we have got a diagram there, so which is an example of a fuse. Okay, you can see the low melting point wire inside. So you see, so you can see the wire that looks like a coil. It's coiled like. Then what happens is that if the current is too much, then this one will melt. Otherwise, if it allows the current, the whole current into the appliance, then it will overheat and the whole appliance will melt, and it can even lead to what? Very big damage or large damage. If you are not in the house, then it is close to something that can also catch fire, then the whole situation will be in a mess. So a fuse regulates amount of current entering in an appliance. Okay, we have got the example of the diagram here for you to see. Okay, now let's look at this continuation. Different circuits need different strength current or different strength of current, and so we need different types of fuses. So this thing leads us to this topic, which is forms of what? Circuits. Okay, so there are different types of what appliances, and these appliances will need a fuse. But the role of the appliance will require a what? The type of fuses that we are talking about. There are some appliances that need a very large amount of what? Current. So it will have a different fuse compared to these ones that takes just a small amount of what? Current. Now some fuses can only handle a bit of heat. Some can handle a lot. We choose the fuse that suits the safety needs of our circuit. Okay, so here self-explained, just supporting what I said. If the circuit overheats because of the electrical current flowing, the fuse will melt and break the circuit to reduce the danger of fire, as well as what? Protecting the electronic equipment. Okay, so that was the diagram. So generally, this is the way a fuse is what is indicated. The conventional symbol for what? Drawing a fuse in a what? circuit diagram is shown here. All right, so let's go to the next topic, which talks about what? Short circuit. What is a short circuit? A short circuit happens when another easier path is accidentally made in an electrical circuit. Okay, so it's just like a shortcut. So a short circuit, for you to understand, I would say just like a shortcut. So if you are going to a mall and then there is this passage that is long, and then there is another one that you can use, and you can go to the mall in no time, then you are short circuiting. Okay, I'm seeing. Let me just check your comment. Sir, I cannot hear. All right. Okay, yeah, these ones are commenting. Okay, then I will just increase, speak a bit louder. Okay. Just a moment. Okay. So what we mean by easier? We mean that the path offers very little resistance to the electrical circuit. As there is so little resistance, the current flows along the short circuit and doesn't pass through the main circuit. So short circuits can be dangerous and can cause a lot of damage to appliances. Have you ever had a piece of toast get stuck in a toaster? Yeah, sometimes it can be a real nuisance. So lots of people are tempted to use their knife to remove the bread. Sometimes it can be dangerous because remember the knife can conduct electricity. So your knife can be a conductor, and what happens is that can act as a short circuit also, and all the current will flow through your knife, and because you are touching it through you, then what happens? You can also be part of the toast, and then you can be affected. Okay. Now, I've been talking a lot. It's now your time to also answer the following questions. But before we go on, I just want you to post any question regarding my presentation so that I can explain. Otherwise, we go straight to the assessment. So I'm just going back to the chat room, and then you can answer your questions. Okay. Yes. Okay, guys. Yeah. So I can see that some of you are giving me the definitions. Okay. Write down your own definition for an electric circuit. A device used in electric circuit is to prevent Okay, that was great. Okay. All right. So some of you are you are giving the correct answer. All right. So I'm just waiting for the what type of energy does a battery have? Okay. All right. So let's go on. Okay, let's go to number 2. Let's go to number 2. What type of energy does a battery have? Okay, yeah, that's good. Keep your answers coming. Okay, so I can see all your submissions. Let's go to question 3. Let's go to question 3. Question 3 says, when a battery is connected to a circuit, it causes an electrical current in the circuit. Explain what an electric current is and why is it possible in metals. Use the word delocalize in your explanation. Okay, so let's go on. Okay, I'm waiting for your explanations, or it's very technical for you. They say when a battery is connected to a circuit, it causes an electric current in the circuit. Explain what an electric current is and why is it possible in metals. Use the word delocalize in your explanation. So I'm waiting for you guys. Okay. Are you sending me your answers for number 3? Yes, an electric charge is the rate of flow past a point or region. Yes. So they're saying, why is it possible in metals? You must use the word delocalize in your explanation. Nyati, that's you have done well, but there is another portion that you have left out. You have explained electric current. That's good, but they say explain what an electric current is. You have done well. Why is it possible in metals? Use the word delocalize. You just need to refer to the first diagrams or pictures that I showed you, and then when the arrows were not well arranged, and then when the arrows were well arranged. So that is where the delocalize or delocalization is coming from. Try to use it to answer your question. Just add a bit to that. Okay. All right. If it's too much of a task, let's go to question 4. I will explain that later for you. Let's go to question 4. Question 4 says, list 3 materials which conduct electricity. List 3 materials which conduct electricity. Okay, metal, steel, okay, Natalie, okay, copper. Yeah, some of you are giving me 1, 2, okay, try to complete it. It says 3, it's for 3 marks. Materials. They say materials. Bootleg. Yeah, but all your answers, Tyrant, I know that all your answers makes 3, but those answers are not for each person. So I want an individual to try to mention or list the 3 materials. Yes, just like Lesedi. Lesedi also said steel and copper metal, that's 2. So I want, who is coming with the 3? So water, Lynn, water, no, water. Okay, so some of you are going to get 1 out of 3 for that question. Some will get 2 out of 3 for that question. Okay, so in effect, question 4 is saying we should lead. We have got, you remember, we have got conductors and insulators. So question 4 is just saying we should list conductors. Okay, so Lynn, you are saying metal, copper, and steel. Yeah, all of them are metals. All right, silver, copper, and aluminium. So that's 3 out of 3. Nyati, Natali, Lesedi. Lesedi, how do you get? I didn't. Okay, copper, a switch, and a bulb. All right. Let's go to question 5. Okay. Says you. Tyrus, please check your spelling for aluminium. Okay. So you now get what what question 4 is looking for. All right. Because your responses are okay. So let's go to question 5. Yeah, Lynn, perfectly. You have plastic. Yeah, that's one out of. Natalie, 1 out of 3 for question 5. Now question 5 is simply saying we should look for what? 3 materials that do not conduct electricity. So materials that do not conduct electricity, they are known as what? Insulated. Yeah. So Bootle, Lesedi, you said paper, plastic, rubber. Okay, so that's 2. Plastic, leather, wood. Okay, Nyati. And Natalie is only mentioning 1. Very good. Tires, plastic, wood, and rubber. Okay. Tyrus, what is plastic and what is wood? What is rubber rider? If you can explain, motivate your answer. I'm just pushing you a bit. Okay. Lynn is also saying plastic, rubber, and wood. It's like some people are copying each other here. I can see the same. Okay, styrofoam, Lesedi, Lynn, Tyrus, Nyati, your answers are the same. Okay, apart from this, give me different answers. List another 3. Okay, glass. Yeah, they copy. Natalie, they copy you. Yeah, I can see that. I can see that they copied someone because their answers are the same. Tyrus, you and your friends, you must stop copying. So who is correct here? You never did. Okay, that's cool. All right, guys. Um, you type slow. Okay, so nobody copied you. But that was very an interesting lesson. Lean. Tone. Okay. And Natalie, what are you trying to write? Leaves, yes. Tissue. Yeah, tissue is a we can say it's a kind of a paper. Asanda. Tissue will fall under what? Insulator. Okay, wood, that's correct. Okay, okay, guys, let's go back to question 3. It's like most of you didn't answer it completely. So the question is saying, what is when a battery is connected to a circuit, it causes an electric current in the circuit. Explain what an electric current is and why is it possible in metals. So let's go back to it before I give you the answers. All right, let's try to push ourselves and get the answer. I can see that the definition is fine, but why? Try to explain it using the word delocalize. Okay, should I start sharing with should I start sharing with you the answers? All right, Natalie. Okay, but I'm sure you guys you can now hear me well. Lisan, you are just joining us. I've not seen your answers. Okay. All right. These are my suggested answers. Okay. Question 1, write your own definition on an electric circuit. Yes. It shouldn't be the same wording as mine, but if you manage to say an electric circuit is closed, complete electrical pathway or system for transferring electrical energy, you are perfectly correct. That's for 2 marks. 2, what type of energy does a battery have? That it is having a potential energy. Now, question 3, which was a problem, it says when a battery is connected to a circuit, it causes an electric current in the circuit. Okay, now they said explain what electric current is and why it is possible in metals. Use the word delocalize in your explanation for 3 marks. So we can say an electric current is the movement of what electrons, or you can say is the movement of what charges. It is possible in metals. So it is possible in metals as the electrons are delocalized, meaning delocalized electrons are electrons that are not localized. They are not put at one. They are not fixed. So delocalized electrons simply means they can move about. Okay, meaning they are not associated with an atom and are free to move through the wire. So you can simply say an electric current is the movement of electrons or charges. Okay, and it's possible in metals because the electrons are delocalized in a metal, meaning the electrons are not fixed, they can move about, and as they move about, they are able to carry what? The charges or the electrons from one place to another. Okay. Um, there are, for question 4, there are many different materials which can conduct electricity. So most of them you mentioned, like the various types of metals, you are correct because they are what? Conductors. Okay. Now let's go to question 5. Question 5 talks about materials that do not conduct electricity. Okay, so here we can mention them. There are many different materials which are insulated, Some of you mentioned plastic, glass, ceramic. Some of you mentioned wood. Some of you mentioned paper. Some of you mentioned rubber. So meaning you were all perfectly correct here. So I allow you. I will allow you some questions before I log off. Natalie, how is human conductible? What are you saying? No, human beings are not conductible, but sometimes you can be shocked because of the current that will pass through, and it in fact is you are short circuited, and short circuiting can be dangerous. Okay, so guys, you are welcome to ask your questions about this lesson. Otherwise, with the lesson will come to an end, and I will see you guys tomorrow. Do you have any question? Guys, I'm asking you questions. Yes, I know. Yeah, I do, Tyrus. You want us to go to, yes. So I will design it, and then I will the next time, God willing, we can do our assessment through the Kahoot. Yes, so that we can interact with it also. Okay. Have you used it before in other lessons? Okay. So I will try to do mine. If I'm able to do it, then tomorrow or probably next week. Okay. All right. Then I will also try to do it so that every Friday we can use it, so that you can interact with it. All right. Okay. Guys, thanks for sharing and for adding, for contributing to the lesson by way of your suggestions. And then I will make sure that I will incorporate it with our lesson so that we can always interact with it and to get our answers right, or just be interesting. Okay. All right, guys. It was nice having you around. See you tomorrow, and God bless you too. And you also enjoy your day. Bye. Nice having you around.